Hello there, hope you're keeping well. Welcome to the wonderful world of radio frequency and electronics engineering. Got a beauty on the bench today for a full feature look at spec test, live off-air testing as well onto a HF antenna, so we're able to pick up all sorts of radio communication transmissions on this later in the video. And we'll do a full spec test on this Kenwood R5000 HF receiver on the Marconi radio test set behind here. We've got the breakout screen as well, so we've got all that ready. They're wonderful communications receiver. You don't get stuff like this anymore. I mean, the build quality is superb, 1980s vintage of course, just like things from that era, made to a much better specification and better build quality than any of the most modern kit that we get today. Very expensive in its time was this Kenwood R5000 back in the day. Well out of my pocket money ability back when I was a young kid. So now I've got one here which we're going to be spec testing. Towards the back end of the video, obviously I'll connect it to an external antenna and we'll use all the different modes that's on this radio and give examples of the superb quality, the filtering on this HF receiver, because having a receiver, be it SDR, be it a modern AOR receiver for example, or other kind of receiver, they don't tend to have a kind of superb quality filtering that some of these older products had. Genuine crystal filters made by, you know, Marconi, HiQ, and other quality crystal manufacturers. So these receivers had some of them better filtering in them, if you like, and bandpass filters that are switched with pin diodes, and also, as I say, the crystal filtering on top. So you know, it really does make the mark in performance and specification when you're listening to HF, having that kind of that kind of filtering ability, and it gets rid of a lot of interference, a lot of adjacent channel interference, harmonic interference, but all that sort of thing all gets dealt with in this sort of receiver. Really high spec, superb communications receiver. I think, if I'm not mistaken, I once saw one of these in the Jane's Defence Manual, and I think the militaries from around the world bought these too, just like the AOR3000 and 2000 scanner receivers. Now, this particular receiver also can be fitted with an optional VC10 board, which is a VHF converter. We do have a button here which we'll look at a bit later. When you press it, it tries to go to 2 meters amateur band or VHF. Basically, the VC10 is an optional feature that can be fitted to this radio. This radio doesn't have that option fitted, it's just the standard 30 kHz to 30 MHz HF receiver capability. But with the addition of the VC10, when you press that button there, it would allow the receiver to receive any mode again between 108 to 174 MHz. So it's quite useful on VHF as well. As I say though, this receiver's factory spec. It hasn't been modified with the VC10 option. Now, the receiver has got a lovely signal meter that's backlit as well, and read all sorts of things on that with dB, relative signal level, etc. We've got memory channel allocation here, which is the smaller digits, which is a maximum of 100 memory channels. And it's very easy to put a memory in just by using these memory buttons down here. In addition to that, we've got a clock here, which you can see it's reading 10:55 at the moment, but we've got 2 clocks on this. So you could, if you wish, set GMT and UTC or whatever time, east time, west time, whatever time you want it in there. We've also got a timer function as well, so we can set the radio to come on at specific times, like an on time and an off time, as well as basically a timer to allow it to go to sleep. So if you were listening to this on your bedside cabinet or something, for example, and you were going to doze off, and you know, you could set the timer so that it'll switch itself off in a predetermined amount of time. Now, we've got all the different modes here as well, with the addition of a digital mode for FSK, frequency shift keying, for like weather fax, facsimile, radio teletype signals, all the sort of data transmission that takes place on HF typically. We can switch to FSK mode, and we can ultimately, I'm in channel mode there, we can switch to FSK mode, frequency shift keying mode, as well as having lower sideband, upper sideband, CW for Morse, AM for amplitude modulation, FM for frequency modulation. We've also got 2 antenna selections here. We can have antenna 1, which is the SO239 socket. We'll have a look at the back a bit later, and you'll see that. And then we've also got antenna 2 here as well, which is for 600 ohm ladder line that can go out to a HF antenna, so we can flick to that as well. And again, there's connections on the back for that. So as I said earlier, the receiver also scans as well, so you can go into different modes. You've got different channel modes, memory in, so you can store memories, you can exit or enter that, you can clear it, you can do all sorts of things where you can enter frequencies as well, because these are the numerical keys just written above the LSB, CWA, MFM keys. All the way along you'll see that it starts at 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. So basically you could dial in a frequency using those keys, and so you know, you can put in, say for example, 1, 2, and then we'll say 2, all those 3s. So you can dial in a radio frequency 12.3333, for example, megahertz. In addition to that, you've got an up and down button here, so you can go up and down in megahertz as well for quick tuning. You can reset the receiver by pressing these 2 buttons. You've got an A and a B VFO, a frequency lock, so if you press that, it means that when you turn the control, ultimately you can't obviously move a frequency. You'll notice behind the tuning knob as well, there's this little silver band there. Now what you can do is you can turn that to adjust how tight the tuning control is. So when you turn that to different ratchets, it means that instead of it just free spinning like that, there's a bit of resistance, and when you turn it that way a bit, then it's more loose, so you can spin it, as you can see there. So wonderful feature is that. So you can, and it's a very nice control is that. It's got a lovely metal. A lot of these modern receivers have like a rubber band grip thing around, which gets all sticky and manky and starts to fade and crack, and you know, they're terrible to get replacements for. This is all metal, so this sort of serrated finger grip thing is all metal. So there's no plastic fantastic or any rubberized components on this. You know, it's built to last. That's the main thing about it. We've got a selectivity control as well. Again, these receivers were built with wonderful crystal filtering in them, and bandpass filters using pin diode switching arrangements. Unlike modern receivers that contain SDR technology and things where the software does the filtering typically, these type of receivers have much better quality adjacent channel rejection and harmonic filtering, and superb band selection, so you can really narrow down signals, and you've got different modes there in the selectivity. So you can have wide, auto, narrow, you've got medium, all sorts of different selections you can have. So you know, really important that for filtering out adjacent channel transmissions, particularly when you've got 2 stations that are very close together on SSB mode. We've got a squelch control for FM and AM modes, so it also works in SSB, because we can use that in conjunction with the AGC, the automatic gain control. Select to switch down here, which we can have at AGC fast or slow. And we've also got a notch filter here, so we can notch out using the button in here, which we'll see in the video a bit later on when we're receiving off-air live transmissions. That notch filter can be adjusted by this control. So the outer is a squelch, the inner is a notch, so you can really get interference out of people's signals. We've got a noise blanker control, so when we've got noise blanker 1 or noise blanker 2 activated, we can adjust the noise blanker thresholds and levels. We've also got the IF shift control here, so you can physically shift the IF frequency. So if there's any images on the IF from adjacent channels, very strong signals that are adjacent to the frequency that you're listening to, as well as having the selectivity control here for the filtering, you can also shift the IF frequency. So the mixer essentially will be working at a different frequency, so we can alter that slightly. So better image rejection as well as part of the selectivity. So with 2 features there, we've got selectivity as well as image rejection. We've then got an AF control as well, so we can turn the volume up and down, and obviously we'll be looking at that. And we've got the RF gain as well, which is this here, so we can adjust the RF gain. In addition to that, we've got an attenuator, an RF attenuator here, which has 0 dB, 10, 20, 30 dBs of attenuation selectable. So obviously in situations where we're getting high level of noise, background noise, where the S meter is reading high levels, on some days when there's lots of global interference on that particular frequency, we can then attenuate that signal as well. So we've got a whole myriad of different things on this particular receiver. We've got a dimmer control as well, which dims the backlight to the meter, as well as the LCD or the LED display. And yeah, so I think next thing to do is probably have a look round the back, and then we'll do a live test with the radio connected to an antenna. Okay, so for this next part of the video, we're going to do some spec testing of this receiver. I'm going to take through some of the most common measurements that are applied to radio receivers, being SINAD, a signal to noise and distortion, a signal to noise and distortion. So the three different measurements there that we're going to do. And typically on FM receivers, we do what's called SINAD, signal to noise and distortion. How we attain that measurement is that we've got connected to the audio output of the receiver a 3.5mm audio lead, jack plug lead that goes into the recorder socket, earphone, whatever. That's then connected to the Marconi radio test set's AF input, which then goes to the AF analyzer, the audio analyzer, the oscilloscope, and in there then we'll be able to see on the screen the sinusoidal output, the AF audio frequency output from the radio receiver of a demodulated or detected AF signal from the radio frequency carrier. So what we're going to do now, we're going to set up a measurement based on the specification. Now we've got a specification here laid down in the manual that talks about sensitivity and selectivity, and the sensitivity quotes are there all in that table, so we can make that comparison with the manual. Now all radio receivers tend to have particularly FM radio receivers with a HF, VHF, UHF, microwave, whatever, they all tend to have a typical receiver sensitivity of round about from about 0.1, 0.2 microvolts where the squelch would open at the lowest level, right the way up to about 0.5 of a microvolt, depending on how good the receiver design is, and its amplification, its selectivity, and its noise floor. So typically most receivers in the world, doesn't matter what they are, where the makes them, etc., will tend to open around about 0.3 microvolt or have good sensitivity at 0.3 microvolt. It doesn't matter whether it's a handheld radio, a base station, a mobile, it's just generally the way that is in radio receivers. If there's a fault with the receiver, i.e. its front end amplifiers are deaf, or there's a problem with the crystal filter packing in, or somebody's been in it faffing about and untuned it, detuned it from where it should be because they've been twiddling things it shouldn't be, then you can find that you might need tens of microvolts, even in some cases hundreds of microvolts, lots of signal in other words, in order to get the receiver to work, which means that it will only be good at picking up very localized signals and not DX signals or long distance signals that are very weak. So we need a good radio receiver that is very sensitive. In other words, it can pick up weak signals from an antenna and demodulate them successfully. However, if a receiver is faulty, you'll need a very large signal in order to achieve the same result, in which case the receiver is deaf, as we tend to call it in the RF world. So what we're going to do is part of these tests as well. We're going to test these specifications on AM, FM sidebands, but we're also going to use different radio frequencies across the radio spectrum capabilities of the radio. We're also going to do a notch filter demonstration. We're going to look at signal to noise and distortion, signal to noise and distortion of the audio output. So signal to noise and distortion is a specification that's used by manufacturers to quote receiver sensitivity. So they will quote figures as per this manual, for example, with a spec, and it will say for 12 dB the signal should be less than 0.5 microvolts. So if it's equal to or less than 0.5 microvolts, for example, and the SINAD is better than 12 dB or at 12 dB, then that meets specification. So the higher the SINAD at that level, the better the receiver sensitivity is. So this book might say 0.5 microvolt meets spec. So if we say need 10 microvolts to get the same 12 dB SINAD point, then the receiver's deaf. There's a problem with it. It could be detuned, could be electronic fault, so on and so forth. So then we need to investigate further. So that's how we do the specification test. On AM receivers, we tend to use what's called SN, signal to noise. Signal to noise is similar to SINAD, except the difference being is that the signal's only applied momentarily, then it's switched off for a period of time, then switched back on. And the radio test set makes a comparison between the on time of a signal and the off time, because you get noise, a hiss, you get noise on what would be a fully quietened or a signal which is weak but noisy. So that exhibits how good the specification is of an AM receiver when we use signal to noise. Same with sidebands, upper sideband, lower sideband, SSB modes. We use SN, signal to noise, for that. So an explanation of what SINAD is. Signal to noise and distortion implies the signal being the audio frequency that's been recovered from the radio. In this case, it's going to be a 1 kHz tone. Now, radio test sets tend only to be able to decode a 1 kHz tone. They're not capable, generally, of decoding a SINAD when the audio frequency is changed from 1 kHz to, say, 500 Hz or 1.5 kHz or 2 kHz, whatever. It's got to be at 1 kHz as the audio frequency, because that's where the SINAD's measured. So you need to keep it at that. Now, the other part of it is noise. So the sinusoidal waveform that we're going to see on the oscilloscope in a moment, which represents the audio output from the receiver, the cleaner the sine wave is, the less noise there is and less distortion. So noise and distortion are a component that's added to the audio frequency. When the signal gets weak and we start hearing crackles and pops and distortion, and weaker parts of a signal exhibit those sort of tendencies. So signal is the 1 kHz tone. The noise is how noisy the tone is, and then how distorted the tone is as well. It should be nice and clean, which it won't be when the signal gets weak. It'll start getting distorted, which you'll see in a moment. So that's what SINAD is, signal to noise and distortion. So let's get on with it then. Let's press the RF gen on, because we've set the radio frequency. We've got a level of 1 microvolt, 1 kHz tone at 2.5 kHz deviation. We're on FM. So I'll put a carrier on. We're getting the audio recovered. We can hear it there, the audio test tone. So as we can see there, with 1 microvolts, we've got clearly a legible sinusoidal waveform representing 1 kHz. We can see the frequency of the sine wave there. We've got an audio speech band filter applied, 300 Hz to 3.4 kHz, because this sine wave we're looking at is 1 kHz. It lays between those limits for that audio filter. So now we're going to switch SINAD on. So we've got a SINAD value now of 26 dB. So let's find the 12 dB point. So if I do RF gen level, and we now weaken the signal, so it starts to crackle and pop and get noisy, as we say, you can see the SINAD level is starting to fall. And it will fall rather rapidly very soon. We're already at 15 dB, 14, it's hovering around there. Start the squelch. So the 12 dB point, I'd say, it depends if it settles down. The 12 dB point is roughly 0.364 microvolts. Now, according to the specification in the manual, between 1.8 to 30 megahertz, it's got to be less than 0.5 of a microvolt for 12 dBs. So I'll point to it in the manual. There it is, look. Less than 0.5 microvolts. So that's good. That more than meets specification. Now at 0.5 microvolts, it actually exceeds specification, as we can see here, because it's reading 19 dBs. So if a receiver was deaf, we'd need a lot of RF signal, might need 20 microvolts for example, in order to get that figure. That means the receiver needs aligning, it's got a problem. So that's a little rundown of that. So the signal to noise and distortion is being measured on that sinusoidal. You can see there's distortion on it, it's popping and crackling, and you can see that there. Now if I fully quieten the signal, put 10 microvolts in, then ultimately you can see there's now no distortion, very little if anything. There's no noise because the signal's quite strong, and all we're now recovering is the 1 kilohertz audio frequency, which has been modulated onto the 28 megahertz carrier. So that's the mark of a good receiver. That's how you know if a specification is correct. Now what we're going to do, we're going to now demonstrate the notch filter, and how I'll do that is I'm going to use two mod gens now on the radio test set. Mod gen 1, as we know, is set to 1 kilohertz audio frequency tone. I'm going to set mod gen 2 up now to a 2 kilohertz tone, and we're going to use a notch filter here to notch out one or the other. So that shows that the capability of a notch filter to notch out the 1 kilohertz tone or notch out the 2 kilohertz tone, and then allow you to receive one or the other. And it's an example of how the filter can reject unwanted interference from a received radio signal, where you've got audio components that are interfering due to close by RF signals that bleed into the reception that you're listening to. So let's turn that volume up a little bit. We can hear the 1 kilohertz tone there. If I go to mod gen 2, I've now set mod gen 2 to 2 kilohertz and mod gen 1 to 1 kilohertz. So now we can hear two tones superimposed on one another. If I press the notch in, and now I can turn the notch, now we can only hear the 2 kilohertz tone, and we can see that's correct because we've got a 2 kilohertz frequency here. Okay, now when I move a notch again, let's see if we can notch out the 2 kilohertz tone and just get the 1 kilohertz tone. There you are, look. And you might be able to do it the other way as well, where you go to the 2K, go through it, which is there, and you can go back to the, there you are, the 1 kilohertz. And now you can't hear the 2 kilohertz at all. And if I turn the 1 kilohertz tone off, you can barely hear the 2 kilohertz tone there. It's totally gone. Now if I turn the notch filter capability off, now you can hear the 2 kilohertz tone. With the notch on, it's totally rejected, more or less, and you can suppress it even more. Look, it's just a bit of fine tuning, that's all. But this is the sort of thing that you can do when you're on a received signal, and you can see it's very sensitive, but almost straight away there, no 2 kilohertz tone. Remove a notch filter, we've got a 2 kilohertz tone back. If I introduce a 1 kilohertz again, so they're both on, and then we can again just get the 2 kilohertz tone back. There you are, look, and then back to 1 kilohertz again. So that's a fine example of the notch filter working on a receiver, and that's how you can check that. So what we'll do now, we'll advance onto AM testing, and we'll do a signal to noise test on that at what's called the SN. Okay, so insofar as making a distortion measurement, why is that important? Well, in FM discriminators, when we discriminate the audio tone from the intermediate frequency, we have what's called a discriminator adjustment, which allows the optimum recovery of audio from the Foster-Seeley discriminator within the receiver. So the frequency modulation is recovered from the carrier by using what's called a discriminator coil, which has to be resonant to a particular frequency. And if it's slightly off tune and it's not quite spot on, it's got a sweet spot as a discriminator coil, then the audio waveform, the audio output, is distorted. So it will be clipped, or it will be, the positive going cycles will be in a better shape than the negative going, or the other way around, and it will basically sound distorted. So the discriminator coil is normally located adjacent to the frequency modulated output from the FM detector chip. So basically this coil needs adjusting. If it's maladjusted, it's distorted. So you can put in quite a large signal, as we're doing here, 10 microvolts at 28 megahertz. So in essence, that's quite a high level of signal going in. If a distortion is particularly high at that level, then there's something wrong. We need to do an adjustment. So if I knock SINAD off a moment and we put on distortion, we've got in this case approximately 1% distortion for that signal. Now if that discriminator coil was maladjusted, that distortion will be reading a lot higher. Again, the manual gives a definition for the distortion and an RF level which has to be applied in order to measure that against the distortion. So this meets specification by far. Now there's another type of distortion measurement we can do as well to test the audio power amplifier for the inbuilt speaker. The AF amplifiers can also be tested into an 8 ohm load, and that tends to be done on some receivers where you have to put an 8 ohm resistor, power resistor across the speakers, terminals, turn the volume control right up to maximum, and then you measure the AF distortion, because some of the audio circuits within receivers need alignment and also bias for audio amplifier stages. For some older receivers don't use semiconductors in terms of integrated circuit audio amplifiers like TDA 2003 ICs, for example, where they're an integrated chip, basically audio amplifier. They tend to use some of the older receivers push-pull transistor amplifiers that have to be individually biased. And so to test the audio power amplifiers on the receivers, you tend to have to make a distortion measurement into an 8 ohm load. The output of the audio power amplifiers terminated into an 8 ohm load. We measure across that resistor into the radio test sets AF analyzer, and then we essentially test the maximum output level from the AF amplifier. However, on most modern receivers, because they have an integrated chip IC TDA type device, which is an IC audio amplifier, all that sort of gone out the window really. It's all the biasing's not there. It's it's all integrated in one chip. So older audio amplifiers tend to use push-pull transistors. Newer designs tended to incorporate the integrated circuits power amplifiers, so in one package. So it wasn't necessary to do that distortion measurement sometimes, but it's always worth doing just to check that the capacitors, electrolytics around AF amplifiers are not drying up, because if they do, then they cause all sorts of weird oscillations and distortions on the output, and you get clipping on the sinusoidal waveform. So that gives you a little rundown of that. But as we can see, the distortion there under the AF level of 972 millivolts, we've got 1% or thereabouts distortion on that. So that exhibits a good audio reproduction. Okay, so let's move on to amplitude modulation now. Okay, so we'll flick to AM. We'll now set up the test set to do AM. Mod Gen 1, level 60%. So we'll just adjust the oscilloscope. And we've now got 10 microvolts going in, 60% amplitude modulation. So now amplitude modulating the RF carrier. We'll just knock the distortion off a second and we'll go to signal to noise. So this is what I was saying earlier, where what happens is on AM measurements is with a signal to noise we introduce a 1 kHz test tone for a short duration of time, and we switch it off for a short duration of time, switch it back on, as you can clearly hear. Then we get a signal to noise dB level. Now, according to the specification, if I now wind the RF gen level down and put 1 microvolt in. Now, according to the information in the manual, it needs to be less than 2 microvolts for 12 dBs. So as we can see, the specification of the receiver far exceeds the specification in the manual. We've got 1 microvolt, which is 1 microvolt less than the rated specification, and yet we're achieving better than 12 dB SINAD, or 12 dB signal to noise rather. That's what I meant to say. 12 dB signal to noise. It's actually 14.6 dBs at 1 microvolt. Now at 2 microvolts, which is the specification in the service manual, it's actually giving more near 20 dBs or 19 dBs, shall we call it, 19.7 dB signal to noise at 2 microvolts, whereas the manual quotes 2 microvolts for 12 dBs. So it's actually better than the specification, the limit spec that the manual gives. So again, that just shows you, how that works, and you can obviously squelch it out as well. So we can test the squelch circuit, that functions. Because like with the FM side, we also test the hysteresis of the squelch opening and closing points as well. So we can use squelch in FM, AM and SSB modes. So what we'll do now, we'll look at SSB modes now on the test set and see what we can do. But again, you can see there with the AM amplitude modulation as well, you can also introduce distortion measurements as well if you wanted to look at the detector, the AM detector's measurement. Again, if you were adjusting the AM detector's sweet spot, if you like, from the recovery of the detected audio from the intermediate frequency, you can tune the performance of the sinusoidal waveform to best you can get it, and ultimately that would then have an influence on the overall specification. So again, the receiver is very sensitive, and we can hear a signal quite low down in RF amplitude, and the automatic gain control is functioning, the AGC. We've also got selectivity filters here, medium, narrow, and then wide filters as well, so we can check they operate, which is correct. So that gives you an example really of the AM spec, and as we can see, we can still hear the AM signal quite well even at under 0.5 of a microvolt. So when I get down to about, I'd say 0.2, that 1 kHz tone is barely legible. So, again, great specification. Just shows you how good it is. Again, we've switched the SINAD on now. As I say, it's user preference really, whether you want to do signal to noise or SINAD. We'll put you can look at the distortion as well at particular RF level, or then you can look at the SINAD, the signal to noise and distortion. So it depends on what the manual specifies whether the measurement needs to take place with signal to noise or signal to noise and distortion, you can actually do that yourself, you know, make whatever measurement you want. But there's no problem there with that SSB receiver. Okay, so let's do some SSB testing now. So in order to do that, we'll need to go into RF test. On the test set, we need to go to the RF single sideband test, and then we've got SSB RX, and we will need to set up the frequency again. RF gen frequency, 28 megahertz, and we've got LSB lower sideband selected, so let's go to LSB. I want the oscilloscope again, and we can, there we go, so that's LSB. So we're generating SSB single sideband lower sideband, again 28 megahertz, and we can tune around it. No problem there, recovering the 1 kHz tone. Let's go to upper sideband. Now we'll change the radio test set now to exhibit upper sideband. So there we go. And it can tune round. So it's all there as it should be. Back to low sideband again. Now what we can do is, again, we can exhibit the notch filter. So if we get the RF level down and we start to introduce noise, and then we can use the notch filter to try and pull out the 1 kHz audio tone better. So we can do that as well. And I think I can do that by going into RX test, turn the RF gen level down here, something like 0.5 of a microvolt or thereabouts. Then going back to, so we can still hear the tone there quite legibly. If I put the notch on, now you see we can notch out the noise, a lot of the noise. That's about sweet spot, just around about there, I'd say. Yeah, about there. Might have another notch a bit further down here. Bit of something there. Got the noise blankers as well, and we've got a noise blanker level. And then the IF shift. So you can see there, we're getting rid of a lot of a noise that would otherwise be on there. And the filters are working, so you can notch out. And obviously when you've got speech there, turn all those off now. When you've got speech there as well, because it's varied in frequency, etc., the notch filter has got a certain bandwidth which you can select through the selectivity switch. And then basically what you can do then is you can notch in and out different parts of the audio spectrum, because it's like a predetermined bandwidth that moves around in the audio frequency ranges. So that's what you can do with that. Again, perfectly good specification at that frequency. No problems on lower sideband, upper sideband. No issues there. Okay, so now we set up another test on 7.2 megahertz this time, and we've got frequency modulation selected, FM. Again, similar test to what we did earlier, just change the frequency. So we'll put the RF carrier on, put the oscilloscope on, as we can see there, when we get the scope set up right, audio level. We've got a signal to noise and distortion level there at 24 dB at 1 microvolt, but decrease the signal, find the 12 dB point. Let it settle. So we'll just leave it to settle a moment. So that meets the specification in the manual. It's actually better than the specification in the manual, so that's pretty good. Nothing wrong with that. So we'll go to AM now, and we'll do a similar test. Set mod gen 1 level 60%. RF gen level. And nothing wrong with that. Now we'll do an SSB test then. So put that at 1 microvolt. We'll go to lower sideband, RF test, SSB testing, RX SSB, set frequency, RF turn frequency 7.2 megahertz. Oops, wrong one. There we are. No problem there. Go to upper sideband, change the mode on here to upper sideband. There we go. No problem. So, I think we've sort of reached the end of the video now, I think, more or less. I think it's just a case of looking around the rear and what connectors on the back and things, and then I think we could sort of wrap it up and go straight on to live on air testing then. So you can hear signals from around the world and listen to live off air signals and listen to the audio quality. So let's just move it round, disconnect that cable, and then we'll just turn it round so we can see what's in the back of the radio. So what we've got here, we've got an external speaker jack, so again we could have connected our AF analyzer there as well. We've got accessory connector at the back for things like tape recorders and things like that, remote control connector. Now had we got that, I think it was a VC10 optional board put in for VHF 108 to 174 megahertz. That will be the VHF antenna there. I would have had a separate antenna on it. Now, as I said earlier, we've got the 600 ohm connection here that is for use with ladder line type connections. So basically you can connect there a ladder line instead of SO23950 ohm coaxial cable. connecting there, you can just do ladder line. You've got a 600 ohm and a 50 ohm long wire potentially, or different types of antenna you can connect, and a ground post in the middle, so you could do that. Now this little window up here is the international voltage selector, so depending on what country you're in, whether you're on 110, 220, 240 volts, etc., you know, you can ultimately select which voltage you are in whichever country it is. And there we've got the Kenwood specification label and serial number as well. So yeah, a nice little radio. Very well put together, you know, metal casing, beautifully made all around, including underneath with a metal stand, no plastic, fantastic on it. Being well looked after receiver, very, very good receiver, wonderful. Anyway, at least you've seen the receiver fully. You can actually set it to do scan modes as well. I think if you go to memory and then press scan, then I'll put 2 memory channels in it and it's just scanning between them. And you can also have 1 memory channel on, say, antenna 2 and 1 memory channel on antenna 1. So say if you've got the long wire connected to the binding post at the back and another antenna that gets optimum performance on other frequencies on the SO239, you can even include that detail in your memory channel as well, which is what I've done here. So it's flicking between antenna 1 and antenna 2, because I've put the 30 kHz frequency on antenna 2 and the 8.9225 MHz frequency on antenna 1. So it gives you the option to do that. Now, not many receivers will allow you to do that, to switch antennas as part of the memory function. So you can do that as well, so I can clear that. It's quite easy to put a frequency into memory because we're in channel mode at the moment, so as I'm literally moving the dial, as you can see, the channel numbers appear. But what you can do is, if you go to VFO mode and say you want to put that frequency in on a memory, you do press the mem in button, and then I think you can move to that and then press enter, or mem in. So now that's on channel 3. So if we go back to the memory channels, we've now got 3 channels in, and you can have up to 100 channels. 00 is a channel and 99 is a top channel, so it's effectively 100 channels, even though you've got 2-digit display, because it's 0 to 99, and 0 is also a channel as well, as you can see there. So it's 100 memory channels, so it's a very good capability. And of course, once you set it scanning, you know, depending on how you configure it, then it'll start scanning round. Obviously, if it's picked up a signal, it will then stop. If it hasn't, then it'll carry on just going round. You can set a time lag on it as well, how long it'll dwell, all that's all settable. So yeah, really good radio receiver. Whoever gets this is extremely lucky, because these are very sought after, very rare to get hold of, especially in this condition and quality of build. Whoever's had this prior has really looked after it. So yeah, that's the overview of a Kenwood R5000. Right, let's listen to some signals on air, some interesting signals from around the world. I'm sure you'll be very interested. Okay, so we'll just have a little tune around and see who's on, and you never know.
I'll go in tomorrow. The chaps I bought it off, you don't get a dipstick on a car engine anymore, do you? The dipstick's behind the wheel. That's me driving it anyway. So it's over full of oil. The car's under warranty, see, so whilst I could quite easily get under there and drain it out, it's simple, so it's easy really. I want to let them do it. So it's got to go into market. There's a little bit of a noise I'm not happy with, and I want them to look at it. There's a very slight issue with the heater motor that they're going to sort out for me. We're coming into winter and I want it warm in there, of course. And lo and behold, Land Rover's have this really great the door actuator still, and of course
Så bruger centralen i hvert fald, så det ved jeg i hvert fald. Så yes, det er det, de kalder hårløden. Så det ved jeg. Men det er jo det, kan du sove godt? Her er gasserne.
He was working all his guys 5 and 8, 5 and 9, and I thought, mate, he's nearly 20 over. So I put a call in. He said, Christ, Steve. He said, you got a new amplifier or something? I said, no. I said, in fact, I said, I'm not using the 8-com, I'm using 500 watts out of the 811. He said, you're the strongest signal I've heard out of Europe, 20 over. So, just having to beat him up at full height, Dave, which I don't often do I, over?
No, well, that's the difference, isn't it, Steve? So, I think I worked him the other day, and I haven't got the logbook open, Steve. I've just got SDR Connect up on the screen, Steve. But, oh no, he was another chap I worked in Canada the other day. I can't think of his name. We have worked him before, but it wasn't Russ. I can't think if I've done any DX today. Maybe Japan, Steve. Maybe one station in Japan, haven't I?
Yeah, very nice. I've worked a huge amount, really. I worked a V7 Tango on 15 metres tonight. British Columbia, Dave, over.
Oh, that's a nice one. That's a good, that's way out to the west, isn't it, Steve?
Yeah, he only gave me a 5 and 5. He was about 5 and 7. But I was pretty happy with that. Because then I worked at Mir. Haven't heard of Mir for a few weeks. I worked at Mir. And so there you go. Can't be bad, mate. Can't be bad. Just really nice to hear 20 metres again, open tonight to VK. But States have been booming through, but just not quite making us some mods on the short path. But tonight it was superb. M0SKA, M0EBJ.
Yeah, very good, Steve. I'll tell you, I worked today, and I've only worked one DX station. It was Amir, 4x6 Tango, 12 metres. But yesterday I worked a special event for a club station in San Marino. I should imagine they're a contest station, getting ready. I worked for a guy on a cruise ship in the Ionian Sea, which is in the Med. I've worked him before. I think Pete was on about him the other night. So I worked him. He was running 7 watts, Steve. And he had an antenna on the balcony in his cabin. And then I worked Japan. Juliet Hotel 1 Golf Echo X-Ray, who we've worked before. Utaka, and then I worked Guernsey, Canada. Yeah, I've done okay.
Ok, abbiamo Antonio, su, guarda questi cari che sono ormai verdi, Now, os colegas lá de cima têm imenso sinal. O nascimento, pronto, eu consigo ouvir, mas está lá dentro, ligado com o ruído, portanto eu consigo.
Japan America 2, Papa America Ontario, correto? Papa Hotel Ontario, 100% Ken Sun.
Nice to meet you on 40 meters, give you 5x9 into Slovenia, strong as usually on the other bands. I'm Janis, how copy today?
President of Peking University in the 1930s. This autobiography reads like a movie script that takes you back to experience what China was like a century ago. Via this work, readers can relive the quiet village life of Chang's childhood, the fast-changing urban life of his teen years, and the... Back here. K0 PKM 589. Thank you, Charlie. Quebec 9 Alpha. Whiskey Papa. YT1 BWP 589. Charlie, Quebec 9 Alpha. Mike Sugar Whiskey. Mike Sugar Victoria. Mike Sugar, Mike Sugar Victoria 589. Sugar Quebec 9 Alpha.
Charlie, Quebec, then Alpha. Good, Victor, Echo 6, Golf November, 5 and 9. Thank you. Whiskey 7 II, 5 and 9. Charlie, Quebec, then Alpha. Echo Mike Mike. Whiskey 9 Echo Mike Mike, thank you, 5 and 9. Charlie, Quebec, then Alpha. Who's Papa? We're Mike Mike 7, Fox Mike, Fox Queen Papa, you're 5 and 9. Thank you. Who's Golf 4? Golf 4 Alpha Fox Alpha, thanks for calling, 5 and 9. 73. Again? Charlie Sugar Italy. Whiskey 2, Charlie Sugar Italy, 5 and 9. Charlie Quebec and Alpha. Mike 9. Mike 9, Wave Victor X for Delta, 5 and 9.
Yeah, Roger Dodge. I mean, at the end of the day, last time I used it, when Russ were alive, and every time I turned it on, it was the same channel what me and Russ used to go on, and
1 Delta Delta, good evening, very loud, 5-9, over. Thank you for calling, good evening, 73, Oscar Yankee 1, Oscar Polska 2 Romeo. Yeah, Delta Lima 2, give me the suffix again. Delta Lima 2, Foxtrot Romeo, Otto, I think. You're 5-7, over. Oh, thank you. Have a good evening, and 7-3. Thank you. Oscar Yankee 1, Oscar Fox. Oscar Yankee 1, Ocean, Florida. CQ80, Oscar Yankee 1, Ocean, Florida, calling CQ.
Auf der Spule und dass ihr das noch in eurem Alter dann noch so macht. Aber ich, ganz ehrlich, würde das jetzt nicht mehr machen können.
Do you on the 101, Brian? I'm just trying to remember it.
I'm on the SBS.
Oh, that's it. Yeah, so I knew it was a Yaesu. I knew it was one of those new lovely Yaesu things. Yeah, quite a nice one actually. I had a go with a 10. When was it? A couple of weeks ago. I did do a modding one actually for somebody, so I put a pan adapter output, a buffer board to go into an SDR, and so I sort of had it apart first when I'd done that sort of working, and yeah, really nice radios actually, very nice.
Dus dat gaat allemaal niet zo makkelijk. Nou, ik weet niet waarom ik dat niet besluit.
Zulu. Wind calm. Visibility 10 kilometers or more. Cloud few at 2,000 feet. Ceiling broken at 3,500 feet. Temperature 13. 08. No SID. Turin Metroport. Turin at 2120 Zulu. Wind calm. Visibility 10 kilometers or more. Cloud, ceiling broken at 2,000 feet. Temperature 12. Dew point minus QNH 1008.
Trying it. Listen, anything to try anything is worth a go in my book, mate. I'm going to buy some ferrite, and I know that Stepper have introduced, or they did introduce some chokes to that you could buy with the recent Stepper antennas before they sold. Well, they gave up the ghost really. They were making some sort of a choke balance up or whatever it would have been. I can't remember what it was. They were doing something anyway with ferrite to try and help the noise that these antennas seem to be picking up. So I'm going to get some ferrite clip-ons here, good quality ones, Type 31 good ones, and get them clipped up around the antenna, up at and
and give it a bash.
But it's, it's not very close to a mint or anything like that, so I'll give it a bash. But I have thought about trying a choke as well. At the end of the day, mate, anything's worth a try, over.
召开。这一万众期待、举世瞩目的历史性盛会将L'Osservatorio Cavalleresco verso la novella Corvo della Gie Ionumino. La convua repertoire 尊重和更多的理解，以及就比如说家长有
教宗也祝愿朝圣者回到自己的祖国时，心中充满感恩之情。 临时想的这个狼狈不一定对。你看啊，如果你永远做的是一个一模。
Diversaj modeloj de la unuj sociaj kulturoj.
October 26, 2025, the frequencies for the Voice of Turkey radio broadcasts will change and be effective until the end of March of 2025. The hours and frequencies for English transmissions in the new term are as follows. The Voice of Turkey's English language transmissions to Europe between 1330 and 1430 UTC will be broadcast in the 22 meter band and on 13635 kHz, and transmissions between 1930 2030 UTC will be in the 49 meter band and on 6050 kHz. English transmissions to Europe, Eastern USA, and Canada between 2300 and 2400 UTC will be in 49 meter band and on 5960 kHz. Transmissions to South Asia and Australia will take place between 2130 and 2230 UTC on 31 meter band and on 9610 kHz. Transmissions to Afghanistan, Pakistan, India, Uzbekistan, and Turkmenistan will be broadcast in the 31 meter band and on 9660 kHz between 1730 and 1830 UTC.
Realmente también las mujeres a la hora de denunciar ni presuman
Sierra aerodrome en helikopter.
complicadísimo acercarse a una mujer, ¿no? Si se siente buscar la ruina, en el teléfono y se busca la ley del CSP, con el CSP se siente inseguro. Y eso se permite a las mujeres de 20 o 20 años. Y eso a lo mejor es que
it's never the same group that were so used to losing last season.
Yeah, no, that feels
like one of the callers said, 4 wins in 17 months. Like,
when it sets in, that rot sets in. It becomes a habit.
Yeah,
It becomes a habit. Yeah.
de solo 29.990 euros.
Por favor, un vermut, un jarro. Jarro.
People, I think Ed Sheeran's very sensible, but very often it boils down to money, really.
Eso no quiere decir de ninguna manera que no se pueda salir de fiesta porque una chavala vaya. Nunca tiene ganas cuando sale de fiesta de denunciar a nadie, de la misma manera que ninguna persona
Lives on, is that Natalie? Is that legitimate?
Again, like it kind of depends, I suppose, like on the intent of it and what it is.
Y cuando una mujer va a denunciar, no tiene ganas de mentir, básicamente porque no lo necesita. Lo que tiene ganas es de quitarse de encima a alguien. Esa idea de que una mujer va de fiesta con ganas de denunciar a alguien, quitémonos la a una mujer va de fiesta con ganas de divertirse. Entonces a mí me parece...
The inquiry had backgrounds in policing and social services. Jess Phillips told the Commons the appointment of an inquiry chair was at a critical stage.
Victims and survivors are meeting prospective.
And that's your lot.